With that being said, let's the third session for the Asia time zone, which is actually the eighth session of the Cosmos DB Conf here, is on GraphQL over Cosmos DB. And where do you start? One of the hot topics, as we see, and we've had a lot of feedback from the customers that this is exciting. Presenting to you Aaron Powell. He's a developer advocate, spent about over 15 years web development, familiar with Ajax, JavaScript frameworks. He's tinkering on trying something new. You've seen him as part of Microsoft's developer advocate, going around and doing sessions. Very excited to have you here, Aaron, and take it away. Looking forward to your session.
Thanks for having me on. So, welcome everyone to our session here today at Cosmos DB conference about GraphQL and Cosmos DB and how we can get started. So this session is going to be a lot of introduction around how to bring these technologies together. And it's a good segue, I guess, from the session we just had, which was talking about how we can model data, particularly thinking that using that SQL API in Cosmos. So I'm glad that we've had that covered off so that we can look at how we can then do some application with that. As I said, my name's Aaron Powell and I'm part of the Cloud Advocates team here at Microsoft. If you want to get in touch with me after the session, ask any questions that I don't get a chance to follow up with before we wrap up today, feel free to tweet at me or send me an email or anything like that. I'm always happy to do my best to answer questions where I can or direct you to someone who might have some better insights into how to answer said questions. But you're not here to hear about me and what I've done and all my career and things like that. You're here to learn about GraphQL and Cosmos DB. But first off, let's talk a bit about what GraphQL is to make sure that we're all understanding the role that it could play and why we're talking about it at a Cosmos DB conference. So GraphQL is a query language designed for doing APIs, whether they're web APIs, so a web application talking to a server, mobile, console applications, or anything in between. We can use it as a query language for any sort of application design. It was originally created by Facebook. Facebook created it to solve a problem that they had around how the client was requesting data in the Facebook newsfeed. So if you think about the way the Facebook newsfeed works, it has a lot of information that's appearing there, and it changes the way that that works depending on the context that you're looking at. So with traditional API designs, whether it's REST or custom-made APIs for a particular service endpoint, you end up having to put a lot of the responsibility of the API design into the server, and the client is just kind of left to consume the way the API works. GraphQL, on the other hand, flips that so that your control is then inside of the client that's requesting. So the client is the one that has the power to say how much data it wants of the available objects that it's querying against. So this makes it a lot more appealing for certain scenarios in which you're going to be building applications. Now, it might not be right for every application, but there's definitely scenarios where it can work well for. Another thing that GraphQL brings in that is quite interesting and is different to a lot of other API design models is the idea of real-time through its subscription notion. So in GraphQL, if you wanted to do something in a real time over like WebSockets, for example, you can use the subscriptions feature of the GraphQL language design that allows you to then connect to something that is happening on your GraphQL server and be notified without having to do something like long polling or any other HTTP approaches to doing kind of real-time approaches over HTTP. It's designed to work with WebSockets. So this can be definite advantages in some scenarios, again, particularly if you're working with an application that has that notion of needing to get real-time feedback from the server that it's working with. So for the application that we're going to build out today, or that we're going to have a look at in a little bit, I'm thinking about this idea of a trivia application. So like many of you, I've been stuck at home and my primary form of social engagement has been over video conferencing platforms, and I've been playing trivia games with my friends. So I decided, well, let's see if I can actually build one or at least model that out. So we have our game object here, and it's going to have things like an ID, the state of the game, like are we currently playing the game, or are we waiting for people to join? Is the game completed? How the players connected to the game, questions and answers, all that sort of stuff. We then have some relationships to other data models that we've got within inside of our Cosmos store. So we have our player, which has got a many-to-many relationship back to our quiz, because one player can play multiple games and one game could have multiple players. And we might want to be able to go back from a player to a game or from a game to a player. We then have questions. Again, they've got some more information on it. And so we can start seeing how this data model is starting to come together. From a GraphQL standpoint, we would then interrogate this by defining a GraphQL schema that says that we're going to have a couple of ways that you can enter our data model. You can request a single game by its ID, and that'll give you back the game object. You can request all the games, and that will give you back an array of all game objects that exist. This might be maybe more of an admin feature, not just everyone can grab access to every bit of data in the system. And then finally, we can get back all the answers that a player has given for a particular game. To then query against GraphQL, we will write up a query such as I've got here on the bottom of the slides, where we go to, we're querying against the game, providing with an ID. But as we saw on the slides before, game had things like state, players, questions, and answers. But in this case, maybe I only want to show who's currently playing the game, or the current players that have joined the game, as we haven't actually entered the game and started off asking questions. So in this case, I'm only asking for the game, its ID, and then the name of all the joined players. So this is where GraphQL is different to approaches such as REST. I no longer am getting back all of this other details that I don't need at this point in time. I'm just getting back what I need right now. So how are we going to start building out this application to work, or this server implementation with GraphQL? Well, we're going to have three primary layers. We're going to have somewhere to store data, some infrastructure to run it on, and then a server that implements the GraphQL spec. So for storage, you're probably not surprised for me to say that we're going to be using Cosmos DB. Kind of makes sense. We're at the Cosmos DB conference, so we probably should use Cosmos there. We could use it with its Mongo API. We could use it with the SQL API. We could use it with any of the other communication formats. I'm going to use SQL in the demo that we get to a little bit, but that's kind of immaterial to how you would be communicating. You communicate with it the way that is going to be best working for the sorts of queries that you need to build from your schema that you've got in GraphQL. Now, Cosmos actually works really well, in my opinion, for working with GraphQL because it has a schemaless notion. So while it does have some pseudo relationship approaches by the way that we can model our data and the way that we can work with it, particularly if you're working with the SQL API, it is still a schemaless database. And while GraphQL is a strongly typed schema, it is really much designed around being used in a schemaless fashion to talk to our databases. So I think they're a great fit to work together. So that's Cosmos DB sorted, but what about the infrastructure we're going to run our server on? I tend to go down the route of using Azure Functions. I like it because I like the scalability I can get out of Azure Functions. It means I don't have to worry about infrastructure in any way, shape, or form. And I tend to either be writing in .NET or JavaScript, so it fits again quite nicely with that because I can run both of those options there. And especially if I'm going down the .NET route and building a GraphQL endpoint, I don't even have to worry about establishing connections to Cosmos DB. I can have that entirely managed by the Azure Functions runtime and get that document client back and get access to the SDK. So I don't even have to think about connection pooling and connection management inside of my GraphQL server. But there is one drawback if we're going down the Azure Functions route, and is that I can't do real time with subscriptions. Azure Functions only allows me to do HTTP triggers inside of my GraphQL server. So in that case, I'm probably going to want to go down the route of Azure App Service. Azure App Service is a way that I can run any thing in a platform as a service model or a PaaS model. So whether it's a .NET application, Node application, Python, PHP, Java, etc., I can run those quite easily with inside of App Service. And because I'm running then much closer to the web server itself and managing scale out and things like that, I have more visibility over the kinds of resources I've got deployed, and that I can even do things like WebSockets. So I can have that real-time subscription notion. These are two options that I would look at first before going down the route of like rolling my own virtual machine or going into a containers approach, because I think both of them can be used really effectively for building a GraphQL endpoint and then communicating through to our downstream services. So we've got Azure, Cosmos DB working with app service or functions. What about the server implementation? So GraphQL is just a spec that you have to implement in some form of a server. In this case, I have two server models that I tend to go with. The first is Apollo. Apollo is an open source project written by a company called Apollo, unsurprisingly, and it's an implementation of a GraphQL server in JavaScript. It's actually written in TypeScript, but that means that we're running in JavaScript anyway. I like it because it's got bindings into Azure Functions, so I can easily deploy an Apollo server into Azure Functions without having to worry about how do I do the bindings with the HTTP trigger, how do I do a response appropriately, so on and so forth. But if I did need to do subscriptions or I wanted to deploy that as a Node server, it's also got bindings with Express, Core, and other popular Node.js web server frameworks. If I'm going down the route of .NET, I would go with Hot Chocolate from Chili Cream. Bizarre name, so it can be a little bit confusing to realize that this is actually a GraphQL server, but Hot Chocolate is going to be really approachable for someone that is very familiar with the .NET and particularly a C# programmatic model. Instead of going down the schema first and designing a schema file, where we'll see in a moment that you'll often see, particularly in JavaScript applications, it uses a type safe and a type first approach, similarly to the way that you would do with like Entity Framework, if you're working with Entity Framework over a database as the storage model. So if that's the kind of programmatic model that you're used to with building data-centered applications, then Hot Chocolate is probably a good approach for you in that regards. Right, so we've got Apollo or Hot Chocolate. That's going to be our server implementation that we're going to run. We're going to put this into either an app service or an Azure function, and we're going to connect this through to Cosmos DB. So let's now jump over, it's probably enough slides for the time being, and actually see how we can go about building one of these servers out. I have a pre-built application here that we're going to go through a number of different steps because, well, for the sake of time, I don't want to spend it all in just trying to build out one single part of the application. But what we've got is an Azure function that is going to then be turned into a GraphQL endpoint. So I've got the starting of this already. If we open up my package.json file here, we'll see that I have the Apollo server Azure Functions node module installed so that I can build this as a GraphQL server running Apollo and deploy to Azure Functions. Inside of index.ts, so this is the entry point for my Azure Functions, I'm importing the Apollo server and a couple of other tools so I can load my schema file. And then I'm also bringing in some resolvers, which are the things that are going to handle the queries that happen. And then this is being turned into an Apollo server, which is then served out by my Azure function. If we have a look at our schema, we'll see that the types that I had modeled in the slide in my crude drawings, modeled as GraphQL types. I have question, which has IDs, correct answers, question, the full array of answers, the game state as an enum instead of just as loose strings, players, etc. And if we scroll down towards the bottom, we'll see that we have the query as well. So the query is then where I have that entry point. So how do I get back a single game? How do I get back all games? How do I get back the answers that a player has made and submitted for a particular game? So this is what our starting point for our application is going to be. And next, let's have a look at how we can go about building those the resolvers to start talking with Cosmos DB. So I will move forward in time by going to a different set of Git commits. And inside of this, I've started modeling out my data model inside of my application. So I have this new folder inside of my Azure function called data/Cosmos. The reason I've got it Cosmos and in memory is because this application has the ability to be run just as an entirely in-memory data structure or as a Cosmos DB one. Obviously, we're interested in the Cosmos stuff today. But I've modeled out some types that I would then use with Cosmos. So I have this base model type, which is containing an ID and what type of model are we storing. So this is then going to be my partition key in the Cosmos containers that I'm working with. I then have a question model, which has those fields that are coming back from my Cosmos database. So question, category, incorrect answers, correct answers, etc. These don't map exactly to what my schema says. My schema is just, it doesn't have the concept of incorrect answers and correct answers. It just has the concept of answers because the user shouldn't see that kind of domain modeling. We want that kind of rolled up for them. But that sort of stuff is what I can have then inside of my database that I expose slightly differently through through GraphQL. And then we've got a couple of other models that are implemented here. And then I have some data stores. So the data stores are how I'm getting Apollo to talk to my Cosmos backend. So I have game, user, and question. So these data sources are a pattern that Apollo provides, is the data source pattern. And then I just put in the members of that makes sense for the kinds of interaction that I want to do. We'll jump into the resolvers.ts file next, because this is where we're going to start building out the resolvers that will be talking to those data sources and then getting the data out of our Cosmos DB backend. Actually, before we do that, let's have a look at how we've connected to Cosmos. So for this, I'm using, there we go, let's just collapse that a little bit further so that we can see a bit more of the code on screen. I'm using the Cosmos SDK from Microsoft. So I get back a Cosmos client and then establishing a connection using the connection string that's been passed in, and then creating these new Cosmos user data source, question data source, and game data source. Let's jump into, say, the question data source and have a look at how that's implemented. I've brought in another node package. So again, this is all built on open source technology. So I brought in a package, which is Apollo Data Source Cosmos DB. This is written by another person at Microsoft that is a wrapper around the Apollo's approach to doing data access that then talks directly through to Cosmos DB. So it provides me with a bunch of APIs such as query by many, which can take a SQL spec query or a string. It understands parameters that can be passed in. I also have other methods on this for doing updates, creates, getting single items, and so on and so forth. But the reason that I'm using this is not just because it gives me some convenient wrappers around the Cosmos SDK, but because it's got built-in caching. So this works with a caching model that is provided by Apollo so that I can pass in a TTL, or a time to live, when I'm doing a query so that I'm caching the data that's happening in there and not having to worry about how long that's been available for or when I'm going to have to get that back. I get caching kind of built in nicely, and I can control the cache level I want on the different queries that I'm performing inside of my Apollo, inside of my data source that my GraphQL application is using. And let's jump over to the final implementation of the application, and we'll bring up that resolvers.ts file that I was talking about. This is, well, it's not doing anything particularly exciting because all it's doing is it's talking to those data sources. So as far as GraphQL is concerned, it's just talking to something that's managing our Cosmos access. And that's really what we get out of by having this level of abstraction through data sources in Apollo. We get this nice simple API. So when a user has requested a single game, I've just said, well, here's a method that will tell you, will get you a game. This is returning a promise of the game model, which is then mapped through into our GraphQL result. I've got this already up and running inside of my browser. So this is the GraphQL playground. So I just launched this from my VS Code instance, and the GraphQL playground is up and running. I've got a query here that allows me to get back all of the games in the application. All the games in my Cosmos backend. So let's kick that off. And we'll notice that I'm pulling back the ID and the state. But I could also be saying, well, I also want players, and then from players, I want name, so on and so forth. So GraphQL allows me to build that out. And because the way that we've designed our underlying data model is a schemaless notion inside of Cosmos DB, I should be able to map that pretty well. But you don't want to map your queries one-to-one between what someone could do in the browser and what someone could do, the actual SQL query that you're going to perform. So that's something that we need to think about a little bit differently in the way that we're working. But we'll execute this query and we'll come back over because I've popped in a breakpoint here, and we'll see that we've ended up here, broken on the resolver for games, which is the query operation that we've just performed in the browser. And then this will come through to get games inside of my game data source, which is then going to perform a Cosmos query, which is against my partition key. So this is just getting everything back. We'll just hit F5, run that through to completion. And there we go. We've got back all of our data. I can perform a write operation. So in this case, it's called a mutation in GraphQL, which is going to create a game. And if we hit execute on that, that's going to add a new game, grab its ID, and then we could create a new query. If we go query, and we say game ID of this, BIHN, yep. And then we'll get back the state. And if we go players, name, there should be no players in the game because there isn't anyone that's there. We'll come back and we'll add, how about we call a mutation, which is going to add the player to the game. We'll execute that. And It looks like I should have probably tested my application a bit beforehand because I've got a runtime error. And this is what happens when you go off script in your own demos. Lesson be learned, stick to your own script. We'll move on from the error. Trust me, it does actually work. And I'm sure if I spent a few more minutes reading the error message, I'd have a better idea of what actually went wrong. But I was just going to finalize by showing how we can do that create and add user to the game. So we'll come down to that mutation, which is add player to game, down here from line 74. So what I'm doing here is I'm going out to the user data source, creating the user, then getting the game, and then updating them. Now, I could be doing this using the Cosmos DB change feed if that was a preferred model to doing it. But I've just felt that it was nice to wrap it up and make it very clear inside of this one GraphQL resolver that this is what's going to happen, mostly because we're going to be returning back the user. I'm doing it all here. But it's definitely the sort of thing that you would look at and go, maybe adding a player to a game, do they need to, should this be talking to the game object itself? I'm not sure. Or is that something that's better handled by a change feed, like management process in the background? But that's something that you decide based off of the needs of the application that you're building. We're just about out of time today, so we'll just quickly wrap up by just a quick recap of what we've done and what we've talked about today. We've had a look at how we can build a GraphQL server using Apollo, or if you wanted to go down the .NET route, you could check out something like Hot Chocolate. We could deploy this into an app service or an Azure Functions. In this case, this was one running on top of Azure Functions. And obviously we're storing our data in Cosmos DB because it wouldn't make sense to be at a Cosmos DB conference and not be showing you Cosmos DB as the storage engine. I'd probably be doing a disservice if I was looking just straight at SQL Server or something like that. If you want to check out some of the projects that I talked about today, Apollo GraphQL and Hot Chocolate, their links are on the screen, or I've provided QR codes if you want to scan those as an easy way to get access to them, because I know that you can't reach out and click the links in my slide deck here. If you want to have a look at the code that I was showing there in those little demos, I created a workshop on building a GraphQL and TypeScript application, and you'll find that on my GitHub at github.com/aaronpowell/GraphQL TypeScript workshop, or follow the QR code. And that goes through a whole bunch of different steps to take you from I've never built a GraphQL server to having a server and a client working together in TypeScript in a type-safe model, working either against Cosmos DB or against a in-memory database. And I've also done a blog series on how to get started with GraphQL on Azure that looks at how we can deploy .NET or JavaScript GraphQL servers, how we can connect them up with Cosmos DB, and how we can do some real-time work with subscriptions. But as I said, we're coming to the end of the time that I had today. I hope that's been interesting. I hope you've learned a few things about how easy it is to get started with GraphQL on Cosmos DB and have that running with inside of Azure. As I said, if you got any questions that I don't get a chance to answer today, do reach out on social media or via email, and I'm happy to do my best to answer them. But again, thanks for having me, and hope you enjoyed the rest of the conference.
Hey.
And the crowd goes wild.
I love it. Love it. Thank you so much for your session. It's great. Couple of feedback questions just here and there that we're hearing. One thing is GraphQL as a query layer over Cosmos DB. What are the trade-offs in actually from the Cosmos database's performance, maybe latency, speed, or even RUs? What were your give and take of actually using the wrapper of GraphQL as a query language into Cosmos database? And additionally, you did choose a partition key, which you showed in your code. So there's probably also a question as to how did you come up with that?
Yeah. So from the standpoint of like, how do you optimize for performance and for RU utilization with Cosmos when building a GraphQL solution? It's, for me, I look at it the very same as if I was building any other kind of application. What is the sort of data structures that I need to store for the kinds of queries that someone wants to access? Now, this does mean it's a little bit more challenging because the client is the one that is controlling how much data they've requested at any given time. So you need to think about what are some of the common scenarios and give people those entry points into where they're going. Rather than just giving them the type schema and saying, well, if you want you can always just get back all of the games or all of the users, things like that, you give them kind of constrained entry points, because that can help you predefine the queries that you're working with. I'd also be looking at how to leverage things like user-defined functions and have those as the things that are actually doing a lot of the heavy lifting with inside of my Cosmos queries, rather than just trying to write a generic kind of catch-all query to cover everything. I'd also look at how we can do data denormalization so that we can have a data object that stores as much of the data as possible inside of itself. So where I had the game object inside of my Cosmos DB, it also then embeds the user and the questions and their answers, rather than having them in separate entities inside of a collection, because that means that I can query for one top level object and then select out the fields that I need with inside of it, rather than having to query across multiple different objects. Then in terms of partition key usage and how do I work out what would be the partition key, I'll commonly have all the top level objects will have some sort of a field that indicates its type, for lack of a better descriptor. So in this demo application that I have, it's called model type, but it would be whatever it is to indicate that this item you're requesting is a game versus a user versus a question, and use that as the initial refinement of the query based off of partition key, so that we know that we're starting with a game and then we're selecting the subfields off of that. Now, I didn't do optimization so that if you are only wanting just the name of a player, we only select that one out. We would select all the fields that are on a player, but that's mostly because I didn't want to go to the depth of how do you dynamically create Cosmos queries that have field selection based off of the input that someone has provided.
The other one that came up is indexing. How does that work with GraphQL versus, do you need to have some sort of index optimization at the GraphQL layer, or are you leaning back to Cosmos DB for doing the heavy lifting?
No, I would definitely be leaning on Cosmos DB to do the heavy lifting from an indexing standpoint. So if I know that there are like the children objects that I would be likely wanting to query across, or that I've got other fields that are on my top level models that I would like to query across, and that are places of initial refinement beyond the partition key, I would definitely index for those. It does mean that you, with GraphQL, because the client is the one that's in control, you do have a little bit less insights into how someone wants to use your GraphQL endpoints and what that means for the kinds of queries you have to predefine. So you want to have some sort of an analysis system that's monitoring those queries, looking at what someone's doing, and trying to identify where you have hotspots in your RU usage, and then do you need to index on them? Do you need to redefine the query that it's got? Do you need to break them out into separate partition keys? Things like that. So rather than optimizing first, because it's really hard to optimize for the way someone consumes GraphQL, I definitely wait till I start seeing some insights from the way queries are being used.
Sounds good. Thank you. The last one quickly was on in-memory, where you had stored things in memory. How does GraphQL relate to scale out as opposed to in-memory for your apps?
So if you're going to store data in memory, it's going to scale out just as well as any other system that's storing in memory. The more memory you throw at the machine, the bigger it's going to get. The in-memory example that I've got there is just so that you can run the demo application entirely offline. I wouldn't be deploying a production application in memory. I'd be using, the only time I'd be using in memory is for some level of cache, unless I was able to go to like a Redis or something like that as a cache model.
Thank you. Thank you very much for your session. We are on time, so it's now time for the next one. So thank you, Aaron.
Thanks for having me.